What's up, guys? Today I'm going to be showing you how to create an election that runs on the EVM. So we're going to be using Remix, which is it's an integrated development environment, which all that means is it's a place to write code. You can store code bases on this and you can run them. It really isn't that complex. As you can see, I already started over here. And I'm going to go through why an election in this decentralized manner might be important and how to actually create one. So for starters, why this is important, just to take a look at how many funds, is it much or many? I don't know. I'll go with many. How many funds go into actually building elections and ballot systems is ridiculous. So we're going to look up the 2020 HAVA funds. HAVA is the Help America Vote Act, which was actually implemented in Bush after he had a close draw with Al Gore in the 2000 election. And if we see for 2020 what we're spending on having polling stations in libraries and churches. Oh, what's up, Betsy? But for 2020, the funds grew up to $425 million just to have people at polling stations to help elderly people vote. So it's kind of ridiculous, especially when you can have this all as open source code that anyone can build on top of and have it running freely for people to vote mobily. So there's a lot behind this and a lot that goes into it, but the actual code to program this really isn't that complex. So what we first want to do is, I'll start fresh. This is the first structure of how an election ballot is made. But wait, let me see if my little screen floats. I don't know why it's not floating. So I'm going to have to do a side screen. But you get to see my mountains, so that's cool. So the first thing you want to do when you're creating a new smart contract, which smart contracts are financial or electoral applications that can run in distributed systems. In this case, our distributed system is the EVM, the Ethereum Virtual Machine, and that's what we're going to be running on top of. So for starters, we're going to want to declare what version of Solidity we use. Solidity is the programming language that is native to Ethereum, and we're going to be using 422. What up, 420? And what we first want to do is define our contract. So for this, we're making an election. So we're going to call it election. Now to actually give structure to this, we create structs, and that'll just be stuff like voter, which is going to have a bunch of variables defined inside of it. And the other struct is going to actually be, what is this? Oh, proposal. So you could also, you don't just have to have nominal elections running on this. You can also have legislative elections where you can vote on specific pieces of legislation and see what the majority is, what the percentage is on who agrees it should be passed. So second struct, proposal, if I can spell. And that will be the first part of our contract. And what we want to put into this is variables. So we're going to find the first variable being weight, so that we could actually allow people to delegate their vote to another individual voter, and that voter's weight will actually carry their initial delegation. And then we're going to want just a Boolean of vote to see whether or not this person has voted before. Also, we're going to want to add in the address for where this delegation is actually going. So address delegate. And then our final variable for voter is going to be the index of the actual voted proposal, and we're just going to call it vote. Keep it simple. All right, so now that we have our variables defined for our voter structure, we're going to move on to the proposal structure. In this, we're only going to have two variables, one being name. It's going to be bytes32 name and a vote count to actually see how many votes have been counted, the number of accumulated votes. Also, this isn't a code base that I drew up by myself. This is one of the initial tutorials for building smart contracts. So this is like a well-known documentation, and I'm just doing a walkthrough on how you actually build this. All right, so now that we have our structures, we can move on to our chairperson. So we're going to create an address for some individual chairperson. It's going to be a public variable called just chairperson. And what this does is it declares a state variable that stores a voter struct for each possible address. So that means each possible address is going to have their own individual vote structure, voter struct. And so how we do this is we first have to make a mapping. And it's going to be a mapping of address to voter. And we're going to make it public. So from here, we're going to take a step back and we're going to look at the proposal again. And we're going to sort of toy around with this and make sure that we have an array to actually interact with proposals. So proposal, we'll give it a blank array. With public proposal. So now that we have our structs kind of centered in this and we can see what's going on, we're going to take another step and go into the constructor part of our election. So what the constructor does, it essentially stores a memory for the proposal names and allows this chairperson, who there are multiple addresses, each individually acting as a chairperson, and the constructor is going to allow them to actually cast or message send their votes. So we do this by declaring a constructor in bytes32 and memory proposal names. Now again, we want the actual functioning code in this to be public, so we're going to declare it public. And we have two interactions in here. We have chairperson to message sender and voters of chairperson. So what this is actually going to do, it's going to take our voters variable and map it out to the chairpersons to give them each an individual vote. And we're going to want that delegated by the weight of each vote in case someone has any delegation behind their vote. Say if there's a senator who people really co-align with, they might have 1 million people backing them and delegating their vote to them. So what this means is every time this person votes, instead of casting one vote, their individual vote will actually account for 1 million votes. And all right, now to get into some basic computer science. This is your Java CS125 part of this. We're going to do a for loop and have an iteration function in here. So this is the classic I equals 0, I less than some length, I plus plus. And all that does is going to iterate up on some variable I until it reaches a certain length. In this case, our certain length is the proposal names. So how far down the line of proposals a certain name is. So proposal names length. Oh, I forgot my I less than. So as long as I is less than proposal names length, as long as this variable that starts at 0 is less than the length of proposal names, we're going to continue to iterate. So we do this by adding I plus plus. Let me just give myself some more room there. And now we're gonna throw a few more variables into here, or not variables, but commands. So proposals, push proposal. And what do we want to do after this? So we want to push our proposals into a given function, and then we want the name of those proposals to also be mapped to I. So once we have this, we'll keep this open-ended. And place name, proposal names of I. And we want to make sure we're starting with the vote count at 0. So we simply do vote count equals 0. And that should allow us to get out of here. That should allow us to actually go through the proposals and map each vote to individual proposals. So this has a lot of power behind it. It's a lot of unintuitive thinking of what you can build with this. But it's something interesting. It's something interesting just to take in. All right, and I want to make sure I close this out properly. So what do I need? I need 2 end parentheses and a semicolon. All right, and now we move on to our next stage. We're done with constructor. So just a recap of constructor. What it does is allows us to go through the proposal names, iterate between each one, check for the actual votes within that proposal, and then map them out through proposal names. And all right, that might not be entirely clear. That might be kind of wrong as well. But I'll leave it there. All right, so the next part, we're going to give a function to actually allow the right of vote for a particular address. So we'll call it function give right to vote of whatever the address is of this individual voter. And we want it as a public domain. All right, so what this means is if the first argument, hold up, I'll get to that. Because what we're going to build is essentially an argument to make sure each chairperson has voted once and only once. So, all right, how we do this is going to be write out our message sender, set it to the chairperson, and that means only the chairperson can give the right to vote. We want that a comma. And then we have some requirements for how this actually works. So require, I don't know what this little exclamation point does, but it does something. Something important, you should know that. And voters, voter, one of our initial variables that we're being used is voted. So, okay. So what this exclamation point does is it will tell us whether or not the person voting has already voted or not. So this disallows for duplicate voting, kind of like the double spend problem, how Bitcoin prevents people from spending a particular token more than once. All right, and then we need an additional requirement. First, we want to close that off. And this is going to be the weight, so how our delegation is actually mapped. So it's going to be a similar structure. Require voters, voter, and instead of doing the voted, which shows whether or not they voted, we're going to do the weight. So how much delegation is behind this individual vote. And apparently we have to set that equal to 0 to start off with. So double equals 0. And all right. And then we're finishing off here. Just one last line of voters, voter, right, equals 1. So to see how once there's at least one delegation, this is going to prove that this person now has a delegation to their vote instead of it being mapped to 0. All right, end with our semicolon. And that's the end of part 1. Like I said, this is all written in Solidity. You could theoretically do this in Motoco if you're writing this in Dfinity, or Rolang if you want to post this to our chain. So there's a lot of different ways to go about this. It's not limited to just one individual blockchain. but I figured starting off with the EVM, it's probably the simplest format. I don't know if I'd say that. I don't know if I'd say it's the simplest format, but it's the best for starters to get their hands on something if they want to get into this. And yeah, that about wraps it up. Hope you guys took something away. Hope you learned about the HAVA Act. $495 million being spent just to have ballots and elections in polling stations. Kind of ridiculous when you can build an election from code.